Hey, welcome back. In this video, we're concerned with animating the character, and that involves a few things. For one, we'd like to change directions. In other words, have the sprite face left or right depending on our movement direction. We're also going to animate the night by using methods similar to what we've used in the previous section. And we're also going to use multiple sprite sheets, since we have different sprite sheets depending on when the knight is idling versus when the knight is running. Let's go ahead and get started. Now we'll start with the direction of our knight. Now scrolling up just under the knight variables, let's create a float, and I'm going to call this right left. And I'm going to initialize it with 1.f. Now our convention will be that a value of 1 means we're facing the right direction, and a value of -1 means we're facing the left. So we just need to set right left depending on our movement direction. Let's go down to our input here. Now just inside this if check, when our direction is not 0, we can set the right left variable. I'm going to check our direction, and I'm going to get its x component and see if that x component is less than 0.f. If the x component is less than 0.f, that must mean that we're moving to the left. So we can set right left equal to -1. I'll use the .f suffix here. Now in the else case, that means direction.x is not less than 0, so we must be moving to the right. So right left can be set to 1.f. Now a simple if-else statement like this is very common, and if we have a single line of code in the if body and a single line of code in the else body, then there's a shorthand for this if-else statement. It's called the ternary operator. This is the only operator in C++ that works on 3 arguments, hence the name ternary. And it looks like this. We start with our condition. That's going to be direction.x is less than 0.f. Next, we use the question mark, and what comes after the question mark is the statement we wish to run if the condition evaluates to true. That's going to be right left equals -1.f. Now, after this, we use a colon, followed by the statement we wish to run if the condition evaluates to false. That's going to be right left equals 1.f. And the semicolon goes at the end here. So this line we just typed is equivalent to this if-else statement. Both of these do the same thing. So I can remove the if-else statement, and we'll keep the use of the ternary operator. So now we have this right-left variable. What are we going to do with it? Well, if we scroll down and take a look at the rectangle we called source, we have a width and a height. And if we scale this width by -1, then we'll get our texture flipped, and the knight will be facing the left. That's why this right-left value is so useful. We're going to multiply this width by right-left. Now let's go ahead and hit run and start debugging. Here's our window, and if we run around, we'll see that the knight faces the direction we're running, at least in the x direction. Perfect. Now it's time to animate the knight. Take a look at this snippet of code from our Dapper Dasher game. We created this update anim data function where we update some variables associated with animating Scarfy. We have a running time, which every frame we update with delta time, and then we check to see if running time is greater than or equal to an update time, which we used 1/12 of a second. Now when running time reaches update time, we set running time to 0, and then we increase our frame count, and once the frame count is greater than max frame, which was 6, we reset the frame count to 0. So we can take a look at this code and use this concept to animate our knight. We're going to need a running time, an update time, in other words, how much time should pass before we update the animation frames, a frame count, and a number for the max number of frames, which for our knight is going to be 6. So let's create these variables. So just under right left, let's add the animation variables. So I'm going to add a comment that says animation variables. Now we'll need a float called running time. We'll use braced initialization, and it'll be initialized to 0. We also need an int called frame, and that's going to be the current animation frame from the sprite sheet. we need an int for the maximum number of frames, and we're going to initialize this to 6. We'll go ahead and make this const as well. And we also need the update time. We'll make this a const float called update time. And we saw that 1/12 of a second was good for this, so we'll use 1.f divided by 12.f. So our animation will update 12 times per second. Now we need to update these variables. So let's scroll down to just above where we're drawing the character. I'll add a comment that says update animation frame. Now we created a float called running time. Go ahead and type out the line for updating this variable. You got it. It's running time plus equals delta time. Well, we didn't make a delta time. You can make a delta time variable if you want, or we can just call get frame time. Now we need to check to see if running time is greater than or equal to update time. So if running time is greater than or equal to update time, that's 1/12 of a second, in that case, we need to increase the frame count. So we're going to say frame plus plus. We also need to reset running time. So running time equals 0.f. And finally, we need to check to see if frame is greater than max frames. If that's the case, we need to reset that to 0. So we can say if frame is greater than max frames, and we can say frame equals 0 right here on the same line. So now we've updated our animation variables, and the most important one is this frame. This frame tells us which animation frame from the sprite sheet we should choose. Now, the source rectangle is where we choose that animation frame. It's going to be this X component of the rectangle that determines which frame to choose. So what are we going to replace this 0 with? That's right, we're going to take the width, that's going to be this quantity here, and we're going to multiply it by frame, and that's what goes here for the X. So we have night.width converted to a float divided by 6, and we're going to multiply this by frame. So frame times this amount. This allows us to select the appropriate frame from the sprite sheet. Let's hit run and start debugging. And there we have it. We're now animated. Now the last issue becomes apparent when we run around. The knight is kind of just sliding around, it's not running, and that's because we need to use a different sprite sheet. It just so happens that we have a running sprite sheet here in our characters folder. So open the characters folder and you'll see that we have two knight sprite sheets, an idle and a run. So we need to choose which one of these to use depending on whether or not we're moving. And this will be a challenge for you. You're going to create two texture2D variables. Call the first one knight idle and initialize it by calling load texture by loading the knight idle sprite sheet. Create another one called knight run and initialize this with load texture using knight run sprite sheet. Once you've done this, then you're going to set the knight texture2D variable. Set it to knight idle if directions magnitude is 0. That means we're not pressing any buttons, so we're not moving anywhere. And set it to knight run otherwise. So if we are moving, then knight will be set to the knight run sprite sheet. Pause the video and do this now. Okay, so let's scroll up to where we've declared the knight variable. We're going to create two more texture2Ds. So the first texture2D will be called knight idle. And this will be initialized in the same way we initialized knight, to the knight idle sprite sheet. Next, we're going to create another texture2D, and we're going to call this one knight run. And for this, we'll use load texture, and we're going to load characters / knight run sprite sheet .png. Now we need to set the knight variable depending on the direction. So let's scroll down to where we're updating our direction vector. Just inside here, we can update the knight sprite sheet. Now this if statement checks to see if direction's magnitude is not 0. If direction's magnitude is not 0, that means we're moving, and we can set the knight variable equal to night run. Now, we can add an else case to this, and if we enter the else case, that means direction's magnitude is 0. And in that case, we can use the idle sprite sheet. So we're going to say night equals night idle. Okay, let's hit run and start debugging. Here's our window, and as we run, the night starts to run. And if we stop, the night goes back to the idle sprite sheet. Excellent. So in summary, we've set the character's direction using a right-left variable, and we set this based on the x value of direction. We also animated the character using a similar technique to how we animated Scarfy in the last section. And finally, we changed sprite sheets based on whether the direction vector had a magnitude of 0 or not. Great job. We're really starting to make this game look dynamic. I'll see you in the next video.